Welcome to Train Signal. I'm Chris Bryant, CCIE number 12933, and this is video 1, Virtual LANs or VLANs. And as you can see, the outline here looks awfully innocent, doesn't it? I mean, there just doesn't seem to be that much there, but there's a lot of information in this particular video and a lot of details. They're going to help you greatly on exam day, but they're also going to help you in production networks. Because VLANs are everywhere. You've got to know why you configure a VLAN, when to configure a VLAN, how to configure a VLAN, some possible connectivity issues. We're going to look at all that in this video. We're going to revisit trunking, and for those of you who are fresh off your CCNA, you've got a bit of a leg up there, but you're still going to learn some details that are not covered in the CCNA curriculum, and they are important details. And we'll wrap this video up with a look at VLAN design. And don't get too wrought up about, oh no, design. These are very general design guidelines that I'm going to show you, and they are actually very helpful in production networks. One thing I want to say before we do get into the lecture here, though, is that you must not underestimate this section. As with the advanced routing exam, the BSCI exam, you will run into situations where you look at the topics and go, oh, you know, I know that stuff. I'm a CCNA. Especially if you just took the CCNA recently and a lot of this is still fresh with you. But there are going to be details in every one of these sections that are pertinent not only to your exam, but advancing your real-world networking skills. And really, that's what it's all about. So again, don't skip this video to get to the harder stuff, because we've got to master the fundamentals before we move on to that harder stuff. And speaking of which, talking about reasons for VLAN creation to begin with, and like I said, for those of you, if it's been a while since you took your CCNA and you don't work with switches regularly, this is a really good review right off the bat. And the most common reason that we create virtual LANs is to prevent the excess traffic caused by a switch's default behavior when it first receives that broadcast. And we can all probably recite what that is. It's going to look a lot like this. Because one of the first switching concepts you ever learned was that when a switch receives a broadcast, it forwards a copy of that broadcast out every other port on the switch. It's not going to send a broadcast back out the same port it came in on. That literally cannot happen. But already we're looking at a lot of traffic. Because here, we've only got 5 hosts. But what if we had a 48-port switch here, and we've got a host connected to every single port, and every time a host sends a broadcast, 47 other hosts are going to hear it? That's probably not what we want. And this is the default behavior, because what we have here is one large broadcast domain. And it's sometimes confusing, especially when you were studying for your CCNA. You think, well, you know, I just want one broadcast domain. I don't want all these multiple ones. Well, yeah, actually, you do want those multiple broadcast domains, and that's really what configuring VLANs is all about. Because the odds are, if we are sending a broadcast out that every other host attached to the switch is getting, most of those hosts probably don't need it. And what are we doing? We're losing twice. Because first off, we're losing bandwidth because we're sending this broadcast out a lot of ports that it doesn't need to go out. And as I'm always saying, everything we do on a router or a switch has a cost. And I don't mean a cost as in a metric with OSPF. I mean a cost to CPU, a cost to memory, a cost to time. So we really want to eliminate as many broadcasts as we can. There's no way to eliminate all of them, and you don't want to eliminate all of them, but we do want to get rid of the ones that hosts just don't need. And creating virtual LANs allows us to do this, because when a switch receives a broadcast packet from a host that's been put into one particular VLAN, as you see here, the PC on the left has been placed into VLAN 10, then that same switch is going to forward that broadcast only out ports that are in the same VLAN. So right off the bat, by configuring a single VLAN, manually that is, because we actually have 2 VLANs right now, and we'll talk about that shortly, we've cut the number of broadcasts in half. We were sending them out 4 ports, now we're sending them out 2. And the same goes for multicast, by the way, because a switch's default behavior regarding multicast is the same as it is for broadcast. So you know what a VLAN's all about, and we're going to talk briefly about a couple of other official reasons Cisco likes to give. You'll see in their documentation, oh, here are 4 reasons you create a VLAN, but this is by far the biggest one. It's limiting the number of broadcasts and multicasts that you've got flying around your network. And I have yet to see a network that could not be improved that only had one VLAN, the default VLAN. And we'll talk about that default VLAN here shortly. Now, one of the things you didn't learn in your CCNA studies, though, is how these host devices get a VLAN membership to begin with. You actually saw one way, and that is a static VLAN, because a host in a static VLAN is going to get its membership from the port's static assignment, as you see here at the 3rd and 4th bullet points I've put on this screen. Static VLANs, you may not even know that had a name, because a lot of people, myself included, when I got my CCNA, I thought, oh, okay, you know, you just do this command under this port and it's in a VLAN. You didn't even know that had a name. But it is a static VLAN, and we're going to configure some of those in just a few minutes. But another concept that you will be introduced to in this course is dynamic VLANs. And what they do is they actually use the source MAC address, or a host MAC address, to determine its VLAN membership. So it's going to look at the source MAC address of an incoming frame and say, okay, this is host AAAAAAA all the way up to 12 A's, and then look at a table that it's going to get and say, okay, we know this person who has this host belongs in VLAN 17. It really works well. The actual configuration of it is far beyond the scope of this particular exam, but there's a lot of VMPS out there. That's what we're going to use, VMPS. And you need to know about this, not just for the exam, but for production networks as well. So we're going to take a look not at the actual configuration of dynamic VLANs, but their operation. And I'll tell you a good site to go to learn how to configure dynamic VLANs if you wish. Now, in that previous drawing, regardless of whether they got their VLAN membership statically or dynamically, again, on the left-hand side, a host sends a broadcast, and the only devices that are going to receive that broadcast are hosts that are connected to ports in VLAN 10. But you know the catch here already, I'm sure, is that not only will broadcasts not be forwarded between VLANs, not only will multicast not be forwarded between VLANs, but no traffic will be. No traffic is going to be able to go from a host in VLAN 1 to VLAN 10 by default. Now, you may have learned, or hopefully did learn, you've probably seen some of these in the real world. We're not going to have any inter-VLAN communication by default. We either have to get a router involved, and that was router on a stick. Remember that? That's a great name for a technology. Router on a stick is not in this particular exam. If you've never heard of it, you really should go out to one of your favorite search engines and just put router on a stick. Actually, I've got a configuration on my website as well, so you can see how that works. There's still some of that out there, but what's getting much more popular is what we call a layer 3 switch. And the buzzword, if you will, that Cisco likes to use to describe that is multi-layer. Most of the people I talk to call it a layer 3 switch. And you don't get introduced to that in your CCNA studies, because there, the important thing for you to get down is just to get down, you know, what happens at layer 2, what happens at layer 3. And that you've got enough to do in the CCNA without being introduced to a device that can do both. But as you're going to see later in this course, I've actually got one of those, and we're going to do a little bit of configuring on one. There are now devices that can switch and route. So if we happen to have devices in different VLANs that are connected to a layer 3 switch, we can configure a routing protocol, and they will be able to communicate without the traffic having to go up to a router and then right back down, because that's what happens with router on a stick. So we're going to take a look at that later, the actual configuration of a multi-layer switch. But in case you had not been introduced to that concept, they do exist. They're getting cheaper, which means they're getting more popular. A lot of schools that I work with and a lot of schools that I know other people work with put those in because instead of buying a new switch and a new router, they just get a layer 3 switch. They're really great devices. So that line now between layer 2 and layer 3, that's getting a little blurred for you because you got one device that can do both. Now I mentioned here that there is another reason to create VLANs, and this one gets mentioned a lot, security. I wouldn't sell it as a huge security feature, but it is true that if we create a VLAN for a network segment and we don't advertise it in any way, nobody's going to know it's there. You could have an entire hidden segment and no other devices would be able to communicate with it. So security is a reason there. And Cisco standard practice, and it's the practice that we're going to use in this course, is that every VLAN should have its own dedicated IP subnet. Every once in a while you might run into a situation in a network where if somebody did some inadequate network planning 2 years ago, then you're kind of tied into what subnet you're going to use. Sometimes the client just ties you into it. But generally, you'll be able to give each VLAN its own IP subnet. Don't try to split the same subnet between two VLANs. And occasionally, though, I run into somebody who tells me, well, you know, we don't use VLANs. And this is the network that we're going to use here. I've got 4 hosts that are actually Cisco routers. Routers 1 and 2, or hosts 1 and 2, as I'll refer to them here, are connected to switch 1, and 3 and 4 are connected to switch 2. And like I said, I'll run into someone who says, well, you know, we really don't use VLANs. And if you're using a Cisco switch, you're using VLANs whether you know it or not. So let's take a quick look there. Let's take a quick look at our switches. And we've got 2 switches, as I mentioned. And here's switch 1, and these switches have just been write erased. They are like routers that came right out of the box, except that I did put a host name on them and no IP domain lookup, just in case I misspell something. And let's take a look then at the VLANs that we either have or don't have on this particular switch. And look, we do. And the first one, VLAN 1, the default, has 10 ports in it. So it looks like we're using VLANs to me. This is the default VLAN, or the native VLAN, and that is a concept that we will keep coming back to in this particular video. The native VLAN is the VLAN that ports belong to unless you specifically put them in another VLAN. So right off the bat, you see that we've got a VLAN 1, and we've also got 4 default VLANs down here at the bottom, 1002 through 1005. And you can tell from the names, they're for FIDI and for Token Ring. And hopefully you'll never have to do Token Ring, but some of us still have to. So you might think, well, you know, let's just get rid of these VLANs. We don't really need them. They are reserved, but we don't need, say, VLAN 1003. So we'll use the no VLAN 1003 command, and we get a little message from the switch that tells us that we cannot delete that one. You can't delete any of those VLANs that you see right there. Even if we took all the ports here and put them into another VLAN, you cannot delete VLAN 1. You can make another VLAN the native VLAN, but you can't delete VLAN 1. No way, no how. So let's revisit then our little network here. We've got 4 hosts, and I'll tell you that we're going to be using this particular network for their Ethernet interfaces. And those are already pre-configured, those are set. And let's go back to the pod then and just see what's going on. We look under Show VLAN Brief, and we can see that all the ports on this switch are in VLAN 1. How can we tell? Help me out here. How can we tell what devices, you know, which hosts are connected to the switch? How can we see the devices that are connected to the switch? If you went into an unfamiliar network CDP is your best friend, because we could see right here at the bottom that a couple of devices named R1 and R2, which are the first two routers, happen to be configured, or connected rather, directly to this device. CDP, I'm telling you, when you go into a strange network, CDP is your best friend. So we've got routers 1 and 2 here in VLAN 1. We also have two separate physical connections to the other switch. But notice, just for now, that 011 and 012 are not in the VLAN. That's interesting. We will revisit that. We will come back to that and see why. Let's go over to switch 2. And when we run show VLAN brief, you're going to see the exact same thing. These are both 12 port switches. They have the same default VLANs, and they have the same problem as far as not being able to delete the ones you're not going to use. They may be unsupported, but they're still there. No big deal. So let's run show CDP neighbor. And same thing. You'll see that routers 3 and 4 are connected directly to this device, and again, switch 1 is connected directly to this device twice at ports 11 and 12, and notice that ports 11 and 12 are not in the default VLAN. As a matter of fact, they're not anywhere. Good thing to note for the future. So right now, all 4 of these devices are on the exact same network. They're on the same subnet. We know that they're in VLAN 1, which is the default. And so right now, they should be able to ping each other. Let's just randomly go to router 1. And we'll get out of that. Ping 172.12.23.2. Can't run ping from my layer 2 switch, no matter how hard you try. And there we go. We can ping all the others, and I'm not going to go to each one and ping all the way around, but take my word for it, they can all ping each other right now. Just to show you what I did up here when I was going around on the pod. If you get that, the problem here, of course, is that the protocol is not running because this is a pure layer 2 switch. Can't run ping on that. So, right now, this is our scenario. And it should look familiar to you. Let's take a look right here. We've got our 4 hosts. And if host 1 sends a broadcast out right now, the other 3 hosts are going to get it. And we could put 44 more hosts, if we had a 48-port switch, that is, on this particular switch. And every single host will keep getting the broadcast. So maybe we don't want to do that. Maybe we want to make kind of a logical line, shall we say, or logical grouping, and we're going to logically group routers 1 and 2 and put them into VLAN 1. 2, that is. We're going to put them into VLAN 12. So let's go ahead and go back on the switches. We're going to go to the switches. We'll run show CDP neighbor again. See what ports they were on. Router 1's on fast 01, router 2's on fast 02. Now I haven't created that VLAN yet, so what's going to happen when I try to put a switch into a VLAN that does not yet exist? That's the first command. We just made it an access port, so it's only going to belong to one VLAN. And right now, it belongs to VLAN 1. And it cannot form a trunk. And we will discuss those trunking modes again later in this video. Yeah, access VLAN does not exist, creating VLAN 12. So that's a good deal. I forgot to make it, but it's not like the switch, tried to throw me a curveball. It went ahead and created the VLAN dynamically for me. So right now, let's go back to our diagram. Right now, host 1 is in a world of its own. It's in VLAN 12 all by itself. It could ping all the other devices just a moment ago, Will it be able to do so now? Will this ping go through? Nope, sure won't. Because they're in different VLANs. They're on the same subnet. They're even connected to the same switch, so it can't be the trunk. But if they are in different VLANs, it doesn't matter if they are numerically and physically right next to each other, logically and physically. It does not matter because they will not be able to communicate because a layer 2 switch cannot handle inter-VLAN traffic on its own. Now what we're going to do is stretch VLAN 12 out a bit and put host 2 into it. Go back to our first switch. 2. Switch port mode access, and then switch port access VLAN 12. Now when we run show VLAN brief, we will see there on the second line under VLAN name that VLAN 12 is active, and under ports you see 01 and 02. Now let's see if we can send that ping back again. This is not automatic, it's going to happen immediately because we just changed a port membership of a VLAN. So if you try to ping it immediately and it doesn't go through, the switch hasn't finished the changeover yet, so to speak, and there it went through the second time. If it's a rule, my personal rule of thumb is if you don't see successful pings by the third set of pings, then there's a problem. Because you have to give the switch a little time. I've seen people do this in production networks and then try to send a ping immediately and say, oh no, it's not going through. You got to give the switch a little time to catch up, so to speak. Now, we talked about those two commands that we had to use to put VLAN routers 1 and 2 into VLAN 12. The first command that I configured was switch port mode access. And what this does, this turns off trunking. This prevents that port from ever having anything to do with a trunk. And when you do that, it means that port can only belong to one VLAN. Because by definition, a trunk port belongs to all VLANs. If you're a little rusty on trunking, fear not, we're getting to that. But then the second command I put in, switch port access VLAN, and then the VLAN number, that is a static VLAN assignment. So now you know that we actually have two different kinds of VLANs, static and dynamic. And the way that you're most familiar with, most likely the method we used here, that is a static assignment. So we ran show VLAN brief to make sure the ports were in the desired VLANs. Always do that. Always run show VLAN brief. If you run show VLAN, you probably get a lot more information than you wanted. And you can see here, there's nothing wrong with running show VLAN, but I just like to run show VLAN brief as well. That gives you the nuts and bolts of what you need to know. And now, of course, for any connectivity to exist between, say, 1 and 3 or 1 and 4 and 2 and 3 and 2 and 4, we would either have to have router on a stick configured, or we would have to have a multi-layer switch. I'm going to try to go between the terms multi-layer and layer 3 switch because you need to get used to hearing them both. A little real world here for you before we hit dynamic VLANs. Every once in a while I'll bump into a connectivity issue with a host, and it's not really related to the VLAN. And here are a couple extra things for you to check. You should always check your speed and duplex settings to make sure they match. You know, sometimes in this field, and I am just as guilty, believe me, I am not pointing the finger here, we forget to look at the basics before we get to the advanced stuff. You know, we jump to the most complex solution for the problem, and that's why, you know, I'm always telling newcomers to the field, always start at the physical layer. Always make sure that whatever you're troubleshooting is plugged in. Always make sure that the cables are fine, and then you can move up the OSI model. So watch those speed and duplex settings on your ports. And notice that I say check your MAC table, your CAM table, your bridging table, and your switching table. Those are 4 names for the same thing. It is the MAC address table of the switch. Some Cisco books actually still call it the CAM table. There's nothing wrong with that, but they really are the same thing. It's also known as the bridging table and the switching table, and you hear those two a lot less often. Now, when you're checking for this, you should get used to trying to use some kind of filter, because this is going to get real big real fast. And if you've got obviously 47 other hosts plugged into this, then this table is going to be huge. So get used to the fact that you have all kinds of filters here. If you just wanted to look at the dynamic ones, you could run dynamic, and those are the dynamically learned ones. So just fool around with that a little bit, because I've seen it rarely, but it does happen that a switch just isn't learning a MAC address the way that you think it should. One of those things. And as mentioned, if we have static VLANs, and that's what we've done so far, it does follow that we have dynamic VLANs. We are not going to actually configure that, and you're not responsible for that on this particular exam. I will give you a link or a suggestion for your search engine to help you find some documentation on it. Cisco.com does have some good documentation on configuring VMPS, because that's what's involved. It's a VMPS. It is a VLAN membership policy server. And the benefit of this is that when a user moves from one port to another using static VLANs, obviously you've got to have that static configuration mapped out in advance on the port. And it may be a situation where you don't know what port they're going to connect to in the first place. This happens a lot on colleges, and it's going to happen more and more and more as our workforce becomes more mobile, that when you go from campus network A to campus network building B, and you just want to connect to a port in the wall there, you want that user perhaps to be placed into a certain VLAN. But you may have another user right behind that that's got to be put into another one. So we've got to have a device or some kind of setup where a dynamic VLAN assignment can be given. And that's what dynamic VLANs are all about. Because your user can then connect to any switch port in the network and be dynamically assigned to their proper VLAN. Now, the VLAN membership is actually mapped to the host's MAC address. So you remember way back when you were studying switching theory, and somebody kept saying to you, you got to remember that the first thing that a switch looks at on the frame is the source MAC address. And we talked about some reasons for that then. That's how the MAC address table gets built. That you may have port security enabled, and that's what port security uses as the password, is the MAC address. Well, here's another reason that a switch will first look at a source MAC address. Because when a frame comes in on a port and it's configured for VMPS, it knows, oh, okay, I got to look up this source MAC address in this table and look at the mapping for the VLAN and put this port in that VLAN. So it works really well once you get it rolling. And what actually happens is that a TFTP server, Trivial File Transfer Protocol server, it's not just for upgrading Cisco IOSs. The TFTP server is actually going to hold the VLAN to MAC address mapping. And anytime the VMPS server is reset, power cycle, turn off and on, however you want to call it, whatever you want to call it, that mapping is downloaded. Now, there may be some changes to that upcoming where the mapping is downloaded dynamically. I've heard of that. I haven't seen it yet. And for exam purposes, we need to know that that mapping is downloaded whenever that server is reset. One interesting fact here about dynamic VLANs is that PortFast is automatically enabled for any dynamic VLAN port. Now, you can turn that off if you want to, but it is enabled by default, which makes sense because you're not going to be moving a switch around and plugging it into the wall to get a dynamic MAC address. You're not going to take a concentrator or, any of those devices. Remember the PortFast warning? Let's call that up. Always good to review this one more time. spanning port fast. And there's our huge warning about port fast that you're hopefully familiar with. Well, you're not going to take a hub or a concentrator or a switch or a bridge or even an etc. and plug it into a wall to get a dynamic mapping to a VLAN. You're only going to do that with a host device. You're going to do that with a PC, and that should be it. So port fast, then, the router and the switch are making an assumption that your device is eligible to use port fast. Couple of tips here as far as the configuration of dynamic VLANs goes. You have to configure the server first before you can make the ports dynamic. I hate to say that because it is common sense. But if you make a port dynamic first, it's got no place to look. So you've got to have a VMPS server all set up. That tends to be the hardest part to get right because you're entering all these mappings. But VMPS is one of those things that once you get it set up the way you want it, it works beautifully. Two other things to remember about making a port dynamic. If you are running port security, and you remember that where the source MAC address is basically used as a password, if you're using port security, you've got to disable that before you make the port dynamic. You also have to turn trunking off, which means you have to make the port an access port. You have to make sure this port cannot possibly trunk because by definition, a trunk port belongs to all VLANs, and the point of having a dynamic VLAN setup is to tell a port, okay, here is your one VLAN. Here's the one that you belong to. Okay? So again, that's really all you need to know to get started with dynamic VLANs. I do urge you to learn more about this. If you use your favorite search engine, I know that Google returns a very pertinent document right at the top if you just put in VMPS Cisco, and it'll lead you to a Cisco doc that will give you an example of this configuration. Like I said, when you look at the VMPS server configuration, you're going to go, oh man. But it's really not that bad once you get started. Now, we talked about the situation, we've mentioned trunking here a couple times. And here we've only got one switch. But here, you know, we've got hosts that are in the same VLAN, but they are physically connected to different switches. In this particular scenario, hosts 1 and 2 are both in VLAN 12, but they're connected to different switches. And hosts 3 and 4 are in the same VLAN, but they're connected to different switches. So we got to have some way for these switches to communicate and allow inter-VLAN, or not inter-VLAN traffic, but VLAN traffic to flow between the two of them. And that's where creating a trunk line and configuring trunk ports on these switches comes in. Because a trunk will allow traffic to flow between directly connected switches. And again, by default, a trunk port is a member of all VLANs. So traffic for any and all VLANs by default can go across this trunk, and that includes broadcast traffic. And we're going to go into some more detail on how we can eliminate more unnecessary broadcasts in video 2, but keep that in mind for right now, because we tend to look at the good side of trunking and say, oh, you know, okay, this will be fantastic, and really, most production networks, you have to have trunks. I mean, they're not a luxury. You got to have them because you're not going to have all your hosts for VLAN 12 on the same switch. It's not going to work that way. But there's a trade-off there that we need to know about, and that by default we are going to have more broadcasts going around our network. Now, the default mode of a switch port does differ between models of switches, so always check your documentation. And I'm going to show you a command here in just a second that you can use to check the switch port modes. But on 2950 switches, which is what we're using in this course, every single port is in dynamic desirable mode by default. And that means that every single port on the switch is actively attempting to trunk. Because all I had to do to create this particular trunk was take what kind of cable? You remember what kind of cable, right? Crossover cable. Physically connect them with a crossover cable, and in just a few seconds, your port light goes from blank to amber to green, and the trunk is up and running. And here is a great command to give you all the information you really need. It's show interface trunk. And here are those missing ports. Remember with show VLAN brief, we weren't seeing these two particular ports. That's because trunking ports don't belong to any particular VLAN. They by default belong to all VLANs. So anytime you think you've got trouble with the trunk line, or you're configuring a couple switches and you want, hosts on VLAN 12 on switch 1 to communicate with hosts on VLAN 12 on switch 2, and they can't do it, the first thing you should check is this trunk line. And if you see what we're seeing here, you're in good shape. Because from left to right, you can see first off that the ports are trunking because they're listed here to begin with. You can see that the ports are in desirable mode. You're not going to see dynamic desirable written out here, but you do see desirable. It's the same mode. You even see the encapsulation type, 802.1q is what's in use here. The status is what we're really interested in right now, and you see trunking. If you see not trunking there, obviously there's a problem somewhere. And the native VLAN, or the default VLAN right now, is VLAN 1. And that is why all of those ports that haven't been specifically put into another VLAN are in VLAN 1. Because VLAN 1 is the default or native VLAN. So we're in good shape right now. And looking at our diagram, though, one interesting thing is, well, let's say that host 1 is transmitting to host 2. When that bottom switch gets the frame, how does it know what VLAN it belongs to? Does it belong to VLAN 1? Does it belong to 12? Does it belong to 34? The switch is going to know that because the frames are tagged by the transmitting switch, and they're tagged with a VLAN ID, and it reflects the number of the VLAN whose member port should receive this frame. So if host 1 sends over a frame and the VLAN ID is 12, when that bottom switch gets it, it's going to look in there and say, okay, only ports that are in VLAN 12 should receive this frame. Now, this is quite a CCNA flashback for a lot of you, because there are quite a few differences between the two major trunking protocols, ISL and .1q. And right now you may be thinking, oh no, I can't believe we got to go through that again. We do have to go through that again, but for good reason. There's some good production network stuff in here as well. And there's a third protocol involved in trunking that you did not learn about in your CCNA study. So we're going to take a look at all of that. Now, the first of the two trunking protocols that we're concerned with is ISL, the Inter-Switch Link Protocol. And the first thing you need to know about it right off the bat, it's Cisco proprietary. It's unsuitable for a multi-vendor environment. If a Juniper switch, a Nortel switch, a 3Com switch gets it, it's all over, because those switches are not going to understand ISL to begin with. That's only one of ISL's problems, though. Another one is that every frame is encapsulated before it's transmitted across the trunk. There's a 30-byte header involved and a 4-byte trailer, and that's going to cause a problem we'll discuss in just a moment. On top of the encapsulation, ISL does not understand the concept of the native VLAN at all, doesn't get it. So every single frame has to be encapsulated, and the reason I say so all frames are encapsulated is in contrast to .1q, which we'll talk about in just a moment. Just a little bit of info about that trailer. It is a 4-byte trailer that contains a CRC value. It's a cyclical redundancy check. And what this does, it ensures the frame integrity. It is not error recovery, but it is error detection. And it's going to detect if the frame was somehow corrupted as it goes across the trunk. So that sounds pretty good, but that's about the only good thing about ISL. Because it's going to encapsulate your frames, it's going to encapsulate all the frames, and the problem that really comes in is that a frame may be too large to transmit across the trunk or anywhere else, after it being encapsulated, because the maximum size for a Ethernet frame is 1518 bytes. And if that frame is already at its maximum when it's about to be transmitted, and then you stick a 34-byte encapsulation on it, it's a giant. It's referred to as a giant. Any frame larger than 1518 bytes is a giant. And it's not going to be transmitted correctly, most likely. We're going to talk about a Cisco solution to this in just a moment. But that is another one of the problems with ISL. But the big one is the sheer overhead. Because, again, everything we do on a router, on a switch, it has a cost. And right now, as it stands, 2 switches running ISL, the transmitting switch has to encapsulate the entire frame. It's got to encapsulate every single frame that's going to go across the line. And they're probably too big to send correctly then anyway. So, in opposition to that then, we've got .1Q. The full name is IEEE 802.1Q. You can say that all you want to. I like to say .1Q. And it's the Open Standard Trunking Protocol. And if you're not familiar with the term Open Standard, that's basically a fancy term for everybody uses it. Or that everybody can use it. If you have a Nortel switch in there and a Cisco switch, you're going to have to use .1Q because that way it's a language they both understand. But there are a lot more benefits to .1Q than that. First off, there's no frame encapsulation with .1Q. What actually happens is a 4-byte header is placed on the frame. The information is actually embedded into the header. And that header is not added to frames that are destined for the native VLAN. So right off the bat, we've got a couple of benefits with .1Q. First off, there's smaller overhead, which means there's actually less of a chance of giant frames, because instead of adding 34 bytes, you're only adding 4. And on top of that, if the frame is destined for the native VLAN, it's not tagged at all. There's no header placed on it. Now you may be thinking right away, well, Chris, if it's not tagged, how does the remote switch know where to send it? Because the receiving switch will know that an untagged frame is supposed to be sent to ports that are in the native VLAN. This is referred to, really, that process of placing that header is referred to as internal tagging. You'll hear that every once in a while, but not that often, but I want to throw that out for you. And .1Q, this is something else I've seen about .1Q, and I'm not sure where this got started, so I do want to mention it to you. The trunking protocols don't change the destination MAC address of a frame. There's no reason for it to. The actual trunking process itself. You remember when you got your CCNA, you'd be asked the questions that involved proxy ARP, what's the destination IP address here, what's the source MAC address here, that kind of thing. But .1Q doesn't have anything to do with changing MAC addresses. And there is an extension, if you will, of 802.1Q where this protocol can send frames that are up to 1522 bytes in size, which just happens to be 1518 plus 4. And that is thanks to IEEE 802.3AC. I just like saying that. That's all the detail I'm going to give you about that particular standard. If you'd like to read the actual documentation behind that, you can just put in IEEE 802.3AC in your favorite search engine, and you'll quickly be brought to the official documentation for that. But that's the deal with .1Q. And .1Q really is so superior to ISL. I mean, there's less overhead. It's an open standard, so you don't have to have every switch in your network be Cisco. I know that's, blasphemy, but there you go. There's less of a chance of giants. There's no de-encapsulation that has to be done at the other end, because let's not forget that part. When a switch gets an encapsulated frame, it's got to unpack it, basically, and that's work. And everything we do on a router or a switch has a cost. Now, most Cisco switches used to support both .1Q and ISL, but that's no longer the case. Because again, the 2950s that I'm using in this course with you do not support ISL. Cisco's own switches don't support Cisco's own proprietary trunking protocol. So I'm going to actually go back to the previous screen and give you a great website that I would like you to become familiar with. And it's not just Cisco.com, it's UniverCD. This is Cisco's online documentation. And in the old days, when a new router or a new switch came in, you'd have engineers fighting over the documentation CD, because they were great CDs, but boy, it could take you 20 minutes to find what you wanted. Now all the documentation and command references are all out there at this particular site for everything Cisco's ever made. It takes a little getting used to on the navigation at first as you drill down to find the exact information you want, but it really is a wealth of information at this site. Any network engineer, administrator, planner, designer worth his or her salt should have this bookmarked. And frankly, those of you with an eye on the CCIE down the road, you should just live there. You should really get used to navigating the site. It's not hard, and it is a tremendous site to work with. So let's take a look then at some troubleshooting with trunking protocols. Again, it's rare that you're really going to have a problem with trunking. It's just so automatic these days. But I want to give you a couple things here that I've run into out in the field. And the first one, there's that speed and duplex thing again. You know, that should be the same on both ports, both end ports. And we mentioned transmitting giants with ISL. Some CAT switches have Cisco proprietary hardware that allow them to transmit giant frames when running ISL. Now, believe me, that's just the tip of the iceberg there. I mean, there's a lot of documentation out there, probably some extra configuration you have to do, but I just want you to know that it's not just going to drop all the giants that it sees. Both switches have to be in the same VTP domain. People run into this one a lot. Be careful. VTP domain names are case sensitive. Finally, if you're working on an L3 switch, a layer 3 switch, a multi-layer switch, whatever you want to call it, you have to make sure that the trunk port is in layer 2 mode. And you do that simply with the command switch port. And we will take a look at that in a later chapter when we're working on a layer 3 switch. I'll show you that that's actually the command, but it's a one-word command. And when you configure switch port, just like I showed there on Fast 010, that makes that particular port a switching port. Because what you're going to have on an L3 switch are ports that are routing and ports that are switching. It's pretty cool stuff. And one more thing I want to mention to you here about trunking, or actually the tagging and encapsulation before we move on to a discussion of the native VLAN, is that I'm occasionally asked, well, okay, I've got the trunk ports down, I know what ISL does, I know what .1Q does as far as encapsulation and tagging. What do access ports do? Well, keep in mind that access ports belong by definition to one and only one VLAN. Therefore, there's no need for an access port to do any encapsulation. There's no need for an access port to tag a frame with VLAN information. So to the question, how do access ports handle encapsulation and tagging? The answer is they don't, because they don't have to. Now, moving on into a discussion about the native VLAN, and this was one poorly documented topic when I started studying Cisco. I'll be the first to say the CCNA and CCNP exams are more difficult than they used to be, but that's what you want. You want it to be valuable. But boy, no one had a good explanation of what the native VLAN was. And it was one of those things where when I read it, I just said, why didn't somebody just say that? And all the native VLAN is the default VLAN. We talked earlier in this video about how occasionally I'll bump into somebody, well, you know, we don't use VLANs, we just use the default configuration. Well, as you recall, if you're using the default configuration, you are using VLANs. All these ports were in VLAN 1 except for the trunk ports, and we moved ports 1 and 2 over into VLAN 12. Now the native VLAN, again, it's the port that it's the VLAN that the port will belong to should it stop trunking as well. It's another definition for it. I just like to call it the default VLAN. I don't use bold and italics very often, but I'm using it here because I've seen in more than one place someone authoritatively say, well, you can't change the native VLAN. And I'm telling you, yes, you can, and we're just about to do that. I'll show you how to do it. I'll show you the command to do it, which is actually right in front of you right now. Switch port trunk native VLAN rolls right off the tongue. And those of you who have trained with me in the past for other exams or seen my many articles on the web know that I'm real big on you practicing in a home lab environment, or at the very least a rack rental environment, because you're going to get exposed to things on the real equipment that you're just not going to get from a router simulator or just reading a book. You've got to get your hands on it. And that way, when you see it in production, you go, okay, I've seen this before. That's what it's all about. You've got to make mistakes, and you got to see these error messages in practice, so when they happen to you in the real world, you know how to handle it, or at least you have a starting point. And you may recall the first time you configured a virtual link, whether it was home lab or production network, when you configure a virtual link on one side, on one router, by the time you got to the second router, you're getting all these error messages, you know, about this ID not found, that kind of thing. Well, you're going to see that here, but I want you to see it here instead of seeing it in a production network for the first time. Now, why would we change the native VLAN to begin with? If you have a situation where you've got a switch, and maybe you just took this job, maybe you're a consultant and you're just walking in, and you've got a couple of switches that are trunking, and they're 48 port switches, and they 40 ports or more on each switch are in VLAN 10 for whatever reason. And I've actually seen that in production networks. If you've got one VLAN that is your majority VLAN, that has more members than any of your other VLANs, that should be your native VLAN. Generally, that's going to be VLAN 1. But if it's not, go ahead and change it. And we're going to do this in production here on our switches on ports 011 and 012. We're going to change the native VLAN to VLAN 12. And what we have to do, we're going to do it on both interfaces on both switches. So you'll get a really good taste of that message I was talking to you about. Because they like to say, you know, you don't want to see anything on an exam for the first time, and this is the kind of thing you don't want to see for the first time at a production network. This is the full command, switch port trunk native VLAN, and then I'm going to configure VLAN 12 as the native VLAN. Then I'm going to go over to fast 012. Oh, I'm getting some errors already. And I'm going to use my up arrow to repeat commands. Switch port trunk native VLAN 12. Well, I got a bunch of messages here. Let's see if we see anything. You know, it's real easy. You know, we're just going to be real honest here. It's real easy to panic when you see something like this, isn't it? The first time I saw something like this when I was studying, I was like, oh man, what have I done? And it looks intimidating, but if you just look at the messages, it's really not. And it's kind of telling you what the problem is right off the bat. Here's a spanning tree error. Received BPDU with inconsistent peer VLAN. And it even tells you what the VLAN is. It's VLAN 1. And they're going to keep coming in, and now we're really getting the messages that tell us what the problem is. It's a native VLAN mismatch. And what it's basically saying, notice it says with switch 2, fast Ethernet 011 and 012 at the very end. If you just take your time and read these, you don't have to memorize a bunch of codes, you don't have to know what every single word means, but if you just remain calm, that's really the key with any error message. You know, you don't want to just go, oh, I don't know. That's telling us there's a problem with a value on switch 2. And frankly, my friends, it's telling us right there what the problem is. It's a native VLAN mismatch. Let's take a look at the trunk and see if that did anything. Well, the trunk is still up. We've got 011 and 012 and desirable. They are trunking and they are in native VLAN 12. But we're still getting those mismatch errors. How far? They were about 1 minute apart. Notice the timestamp here, 07:07:58, and then 07:07:08:58. They were 1 minute apart. So let's look at show spanning tree for VLAN 1. That doesn't look good right there, does it? That BKN with an asterisk, that does not look good. We want one of those to be in forwarding. How about VLAN 12? Now, this doesn't look too good either, because our trunk ports, you know, the trunk is still up. The trunk is still up. We used show interface trunk, and right there it looked like everything was fine. And now, here's where, frankly, in production networks, we start separating the real engineers from the people who give up real easy. Because I've seen people say that configure just what we've done and say, oh, well, the trunk is up. Well, yeah, the trunk's up, but we can't send any data across it. Because so far for our couple of VLANs, VLAN 1 has members on both switches, and both ports were in blocking mode. And I can tell you right off the bat, that's not good. So the problem is, you already know, most likely, is that switch 1 is saying, okay, the native VLAN is VLAN 12, and our second switch is saying, no, it's VLAN 1, I disagree. So we got a real mess. Fortunately, it's very easy to fix. We're going to run the exact same commands on this side. Switch port trunk native VLAN. Then I'm going to up arrow and back to port 12. There we go. Yeah, we may have to give that a few minutes. Let's see. So far, see that? We're already getting a message. And again, the key is to remain calm. Just because you haven't seen it before doesn't mean you can't understand it. Just look at what it's telling you. Spanning tree, unblock port. Unblocking this port on VLAN 1. Port consistency restored. That's what we want to see. So let's bring that back up and go back over to our other switch, switch 1. Those ports out of, yeah, you see one of the ports is in forwarding, the other one's in learning. Now, why are both of those ports in forwarding mode? Remember why? Because it's the root bridge. Let's go over to 12, excuse me, to switch 2, show spanning VLAN 1. And since this one is not the root, you see that one of the ports is in forwarding mode and the other is in blocking mode. So the key there, a couple of keys there actually. You know now what the native VLAN is all about. You know what its importance is. You know a scenario where you might want to change it. If you have switches that just have a lot of ports in a VLAN that's not VLAN 1, you might want to change the native VLAN to cut down on the headers. But the key here is, with any error message, and it's the hardest thing to do in a crisis, just remain calm. Because whatever it is, it can probably be fixed very quickly. And if you just read the message and see what it's telling you, and don't give up and keep digging, keep using your show commands. That's why I use so many of these. That's why we use only real equipment in my courses. Is because that's the kind of thing you're only going to see on real equipment. No router simulator is going to do what we just did. And you got to know that stuff. So now I know you will be happy. We are not going to talk about ISL and .1Q much longer. I know you're tired of hearing about the native VLAN, so we're going to move on here. And what we're going to talk about is a third trunking protocol. But it's the negotiation protocol itself. And it is called Dynamic Trunking Protocol, or DTP. And this is a Cisco proprietary protocol. And this is the actual negotiation protocol. It is actively attempting to negotiate a trunk line with the remote switch. And that sounds great until you realize that these frames, DTP frames, are transmitted every 30 seconds out every port that is configured for trunking. So maybe we don't want to do that. I mean, if we want a trunk, then we want a trunk. And what I do in the field, and what I recommend to you as well, is if you're going to have trunking ports, go ahead and hard code them to be trunk ports. And I'm going to show you how to do that in just a moment. We've talked about how the default is dynamic desirable. And that's okay, but dynamic desirable, you know, the trunk comes up and everything's great, but a DTP frame is going to be sent every 30 seconds over all of your trunking lines. You know, hey, are you still trunking? Hey, are you still trunking? Hey, are you still trunking? We don't need to do that. So if we want it to be a non-negotiable trunk port, we don't need a negotiation frame or a negotiation protocol running. Makes sense, right? So DTP can be disabled with the switch port no negotiate command. I'm going to show you another one of those errors again that you really only see when you're working with the real thing. So let's run show interface trunk again. I'm going to show you a variation of this command. Notice that this shows you every interface that's trunking. If you want, you can knock it down to the exact interface by specifying it right here. Let's take iOS help. I told you not everybody can remember every command. There we go. It's show interface fast 011 trunk. So if you're looking at an interface but you only want to see its trunking information, you can just use the word trunk right at the end of show interface and then whatever the interface is. So right now we see that this particular port is running in dynamic desirable, that is the default, and what its encapsulation type is, the native VLAN status of trunking, everything's good there. So let's say that we want to turn DTP off on this particular interface. We don't think we need it. So we're going to go to fast 011. And we're going to look at iOS help here. And we got quite a bit of information here for switch port. And here's the command I was telling you about. Switch port no negotiate. Device will not engage in negotiation protocol on this interface. So hey, that's no problem. We'll just type that in. And it's rejected because there's a conflict between no negotiate and dynamic status. That's why we have to know the default, my friends, because dynamic means we're always trying to negotiate, but if you cut off our negotiation protocol, how are we going to negotiate? So what we need to do then is make this a hard-coded trunking port. We want to eliminate the negotiation and say this is a trunk port and that's it. And you remember that we use switch port mode access to make it an unconditional access port. Well, again, here are our three choices at this point with the switch port mode command. And like I said, I don't care if you're a CCNA beginner student or a 3-time CCIE, you're still going to use iOS help. And here's one reason to do it. It shows us the different modes we can set this port for. And the bottom one is the one we're interested in. Set trunking mode to trunk unconditionally. And I believe you'll see that there are no options after that. If you just see the CR when you use iOS help, that means there are no other options, but this is a valid command. So we'll hit enter. Now we've got ports on the switches that are in different modes. Fast 011 on switch 1 is in trunk mode, but on switch 2, the matching port is in dynamic desirable. We're going to see if that causes any trouble, but meantime, there I entered the switch port no negotiate command, and there was no problem. So not only do you need to know, say for an exam, what command turns DTP frames off, the negotiation frames off, but you got to know that you got to make it a trunk port first. And revisiting those switch port modes there, and I'll tell you what, yep, switch port mode. Let's bring them back down here at the bottom. A little easier to see. Access and trunk If we configure those, that's just what they're going to be. There are no options. But we have a couple of options when it comes to dynamic, auto and desirable. Now, going back to trunk mode, I want to remind you that this means just that this port is in unconditional trunk mode. Even the switch says so, so it must be right. Cisco would not lie to us. Well, they would, but they're not lying here. And this port cannot be an access port, and turning off DTP is a great idea once you do this, because again, if you're not negotiating, you don't need a negotiation protocol. Now, dynamic desirable, notice that dynamic actually has two options. This is the default. And what it means is, if the remote switch port is running in trunk, dynamic desirable, or dynamic auto, a trunk will form. And that's because this port that is in dynamic desirable mode is sending and responding to DTP frames. And it's like I said, with 2950s, all the ports are in dynamic desirable. Plug a crossover cable in, and bam, 10 seconds later, you got yourself a trunk line. Now, the oddball mode, so to speak, is dynamic auto. Set trunking mode dynamic negotiation parameter to auto. That sounds real pretty. I wonder what it means. Well, what it means is that this port, if we put it in that mode, will not actively negotiate a trunk, but it will accept negotiations begun by the remote port. So as long as the remote trunk port is dynamic desirable or trunk mode, then this mode is okay. Now again, I want to remind you, let's take a look at this. Show interface, fast 011 trunk. You can see now that when we hard-coded it as put in trunking mode, it's no longer in desirable mode. It's on. So we're going to go over to switch 2 and run the exact same command, because this is the port that switch 1's trunking with. And you notice this one's still in desirable. There's no problem with that. Ports that are going to form a trunk do not have to match as far as the trunking mode goes. But there is a chance, a slight chance, that you can have a dynamic trunking mode configured on both sides and you won't get a trunk. And you see it here. I put, just in writing each one of those three modes. But the fourth note down, again, I remind you that these trunking modes don't have to match on the end ports, but if both ports are in dynamic auto, no trunk will form. That sounds more like an exam trick question than anything else, but I've seen that in production. It's like, yeah, I configured it in dynamic and, no trunk ever came up. Well, they were both in dynamic auto, both ports, so you're never going to get one like that. They're both end ports are just going to sit there and say, okay, I'm ready to form a trunk. Go ahead and send something over. But nobody ever does. Now you'll notice that when we looked at the modes again, there were, or was, no off setting. Switch port mode. There's no trunk off there. There's nothing there. And there's nothing here for a dynamic. I mean, if it's dynamic, it's not going to be off. So how exactly do we make a port untrunkable, so to speak? How do we configure a port so it can't be trunked? We configure it as an access port. When we configure it as an access port, it can belong to one and only one VLAN at that point. Now you may have noticed, let's bring a switch back up here. Let's take a look at show VLAN brief. And then finally show interface trunk. A lot of people don't even know about the show interface trunk command. It's very helpful. Very helpful stuff. You see now we've been concentrating on the ports and what their modes are and the encapsulation and the status and the native VLAN. And that's all important stuff, but those lines underneath are very important as well. you can see by default that all VLANs are allowed to go across a trunk line. And you can see the ones that are allowed in active and management domain 1, which is the default, the native VLAN, and 12, which is the only one we've created to this point. And then the VLANs that are in spanning tree forwarding state and not pruned. And those are 1 and 12 as well. Those should match. The ones that you see under allowed and active and management domain and spanning tree forwarding state and not pruned, those are usually going to match. If they don't, you may have a little problem in there. But what I want to show you here is that you are going to have situations in production networks, as well as most likely on your exam, where you don't want to allow all VLAN traffic to go across the link. And we can use the switchport trunk allowed VLAN command and its many options to really tie down what VLAN traffic we're allowing to go across our trunk. And let's bring that command up, because I'm going to tell you right now, this is more of an art form than anything else. You just have to experiment with this command. It's switchport trunk allowed VLAN, and then we're going to use iOS help to show us the options. And you can see that we've got word, which means we can refer to the VLAN IDs by name, VLANs by name if we gave them names. Add, all, accept, none, and remove. And the first one we're actually going to look at is accept, because what we're going to do is follow that option with the VLANs whose traffic will not be allowed across the trunk. Just for fun, what we're going to do is configure this switch so that traffic for VLAN 1000 cannot go across the link. We'll just pull that one out of the sky. Accept, and then you see the word VLAN IDs. We're going to name 1000. And we're going to go to 012 and do the same thing. Switchport trunk allowed VLAN. And then do a quick show interface trunk again. And now you see something totally different, as they say. Under VLANs allowed on trunk, VLAN 1000 is no longer allowed. You're going to have to be in some specialized situations to use this command. Those of you looking at the CCIE down the road, this one and about 1 million other commands are good ones to know. But this is a good one for your exam and a production network, as occasionally you may kind of be up against the wall. You want to disallow a VLAN. You want to add VLANs back. Adding them back is no trouble at all. All you're going to do, and we can add 1000 right back as well, is use the add option. And we'll put that on both ports as well. And now we're going to use the add option to add 1000 back. And let's see how quickly that took place, that took effect. Very quickly, because you can see now that all the VLANs, again, are allowed on the trunk. Again, I would not say that this is a command that you're going to use a great deal, but it's still a good one to know. And just for fun, let's disallow all of them. This is why you want your own practice network, because if you do this at work, you're going to get fired and sued. So don't do this at work. Do not practice at work. Let's say none. We're not going to allow any VLANs. Can we do that? I'm a little surprised the switch lets us do this. Or at least doesn't say, are you sure you want to do this? Now, no VLANs are allowed on the trunk. And of course, if none of them are allowed on the trunk, then none of them are going to be in forwarding state. None of them are going to be allowed in active. So we can just add them right back. Switchport trunk allowed VLAN all. And we'll put the same thing on 012. Same command. And show interface trunk, you can see just that quickly that we're right back in business. Now we're going to move into a brief discussion of VLAN design. And it is brief because I know from experience that it's really difficult to learn any design from a book or a video boot camp or anything unless you're actually doing it. Because let's face it, with routing protocols, with switching protocols, with a lot of the VLAN that we've configured here in this lesson, there are absolutes. There are absolute right answers and absolute wrong answers. And with design, it's so dependent on the network that any network design is like a snowflake. I mean, no two networks out here are alike. Any of you who have ever done any project management where you're looking at a network that's getting a complete overhaul, it's an amazing challenge because you're going to have some legacy equipment somewhere that nobody wants to get rid of. And of course, we always see legacy instead of old. It's always going to be a new challenge. So it's impossible for any book or any instructor to say, here's the design and this is the way it's going to be. But what we're going to do here is I'm going to introduce you to a couple of VLAN design terms you need to know. And if you work on campus networks, you'll probably have heard these already. A couple of facts you need to keep straight for the exam. And the most important thing about VLAN design is to use that Cisco 3-layer model that you learned about in your CCNA studies. Remember, you just memorized them from the inside out, you know, core, distribution, access. Okay, got that one right. Next question. That's not just for show. We're going to use that model a lot in this course. And as you're going to see as we go into more complex lessons later in this video, as far as quality of service goes, as far as VLAN maps and VLAN filtering go, you really want to keep the workload off the core switches when it comes to the little things. And that's why I put that in paren. I mean, everything that we do is important. But when you get to the switch design, the core switches need to be left alone. They need to be left to what they do best, and that is switch, and switch very fast, because that's the heart of the entire network. And you don't want them doing a lot of QoS, and you don't want them having to do things that they shouldn't have to do, or that the access and distribution layer switches should be handling. So if you don't quite remember the model, believe me, you're going to get real familiar with it before the end of this course. This is part of the video. I do recommend you come back to this after you've done the more advanced videos, after you've completed the course actually, and then the design will make a little more sense. And the first term that I need to introduce you to is the end-to-end VLAN. And an end-to-end VLAN, the name is the recipe, because an end-to-end VLAN is actually going to span your entire network. Now, the physical location of the user is unimportant because that user is going to be assigned to a single VLAN and that's it. And you could see where dynamic VLAN assignment would really come in handy here. So maybe it's a good idea after you get your CCNP to look up some VMPS and get familiar with it, because there's a lot of VMPS out there. But here's kind of the problem with end-to-end VLANs. They use what we call the 80-20 rule. And you may have heard a different 80-20 rule in a different part of your life. But this one is for networking. And it's where 80% of the traffic stays in the local area, and only 20% is going to traverse the network core heading for a remote destination. Because not only we want to keep the workload off the core switches as far as, you know, quality of service or any additional configuration goes, but we want to keep all the traffic off the core that we really can. And by definition then, end-to-end VLANs have to be accessible on every access layer switch. And when you're trunking between access layer switches and distribution layer switches, you're going to have to be able to do that for all your VLANs. Now, this is a very simplified drawing of a typical network setup where we've got a host. The host is connected to a segment or directly to the switch. Switch is connected to a router, and then the router's got two WAN connections, one going out to the internet and one heading for a corporate server farm. Now, the server farm, you know, if you're not familiar with that term, it's just frankly a whole lot of servers that the one corporation or one company owns. And it's usually not going to be in the same office building with your workers, and especially if you've got a campus network, there's no way it can be. So there's a good chance that your users are going to have to go out and have a routable address to get out of there to hit the corporate server farm. It's not necessarily the case, but it probably is. And let's face it, 5 years ago, it was really simple for, say, a school to say, okay, we're worried that the kids are spending all their time, gambling online or whatever, and we're just going to cut off internet access except in the library. And that was easy to do back then. I talk about 5 years like it was a long time ago, but in technology, 5 years is a long time. And now, though, with schools, they're like the rest of the world. There are so many web-based applications that schools use. Macintosh actually hosts some of these applications for the schools. And this is great for them, but those schools have to be able to get out to the internet. So it's not really a good idea to try to implement a scheme where 80% of the traffic is going to stay local to the segment. I don't really know that that's very possible anymore. But that is what an end-to-end VLAN is. It is a network setup or VLAN setup where 80% of the traffic stays in the local area and 20% and 20% only approximately will leave. So that's the theory, but as you can see, it may not be really achievable in today's networks. Now, local VLANs, they use the 2080 rule, and yes, this would be a good idea to keep these two things straight for your exam. Your 2080 rule and your 8020 rule. Local VLANs, 20% of the traffic will be local in scope and 80% of it will cross the core. That is a lot more likely than an end-to-end VLAN. And also here, users are grouped by location. And really, that's it for the design part. These are terms, you do still hear them out there in production networks. They are still used. But again, design is always changing. Now, there used to actually be a CCIE for design, and I think they got away from it because it's so arbitrary how you would judge someone else's design. And especially today with all the different networking devices hitting our networks, there's no way that you can have a cookie cutter model and say, here is the way you design this network. Not going to happen. So now that we've looked at that, I would like us to take a few minutes here and do a command review. We're going to do one of these at the end of each section. And these are commands. You should know the output of them. You should know what you expect to see, how to use them for troubleshooting. We're going to review each one of these here on the live racks as well. And again, I would urge you, if at all possible, and even if impossible, to go ahead and get your hands on some real equipment. Go ahead and put your own home lab together. It just doesn't cost that much money. You can sell it when you're done, and it's just the only real way to learn these technologies. I do have some articles on my website, thebryantadvantage.com. You're welcome to visit the Home Lab Help section there, where I've got about 25 different articles on what kind of equipment to look for, what kind of cables you're going to need, all that kind of stuff, because I know it can be a little intimidating at first. Okay. First, let's look at Show VLAN Brief. And this is really where it all begins as far as troubleshooting goes. You're called in, got a couple of new hosts on the network that can't ping each other, having some kind of connectivity issue. It's probably a VLAN issue. And again here, you can certainly run the full command, which is Show VLAN. But you're going to get a lot of information there at the bottom that you don't need. Because what I'm really looking for when I start troubleshooting is looking at those ports. Do I have the right ports in the right VLANs? And that sounds simplistic, but I'm telling you, when it comes to network troubleshooting, it usually is simple. It's usually a fairly simple situation. It's nothing real complex. But I admit that as engineers, we tend to jump to a more complicated solution, and we don't just say, oh, well, let's see if the ports are in the right VLAN. Maybe that would help. Let's see if the router's on. That would help. So Show VLAN Brief, very helpful. Gives us the status of our VLANs, the numbers and the names. If we have named them after departments, we can see that here as well. So the next command you want to be very familiar with is the switch port mode command. And we've got a couple of options there. So let's look at those options. And you see we've got access, dynamic, and trunk. When we make a port an access port, that's the first step in placing it into a VLAN, because an access port will belong to one and only one VLAN. If we set trunk here, the port is unconditionally a trunk port. And if we use dynamic, we've actually got two choices after that: dynamic desirable, which is the default, and dynamic auto, which means, yeah, I'll form a trunk, but the other side has to initiate it. So if both ports are in dynamic auto at the two ends of a trunk line, you're never going to see the trunk come up. Let's take a quick look there and see what the config looks like. Yeah, it's just no IP address. Okay. Switch port access VLAN X, where X is the VLAN number. That is the second step in putting a port into a VLAN. That, of course, is a static VLAN configuration. Show interface trunk. Very important command. And again, if you want to run show interface fast 011 trunk, that's fine, however you want to run it. You see here the ports that are trunking or attempting to trunk. You see that the mode that they're in, the encapsulation protocol that they're using, their status, trunking or not trunking, and the native VLAN, which is still set to 12 here. And let's do a quick show interface fast 011 here. And this is where I mentioned you want to look out for your speeds and your duplex. And you can actually see that under show interface, that this one is full duplex and set for 100 meg. And that's what we would expect. So you can see here that this router has received 1,800 broadcasts. It's a pretty good amount of broadcasts in the last 5 minutes, so we got a lot going on here. You see the number of multicasts that have been sent out. And as we were saying earlier, there's the number of runts and the number of giant frames that this particular trunk interface is seeing. Remember, the runts are frames that are under 64 bytes in size, and the giants are over 1518. So when you start seeing numbers accrue there, you got some kind of issue. Could be a port speed, duplex issue, a whole lot of different things that could be. But that's the first step, is detecting it, and show interface is a good one to let you see that. Switch port no negotiate. We talked about that. That turns DTP off. That's dynamic trunking protocol. And we can just try that right here on 08. And it is switch port no negotiate. And as you recall, since these ports are in dynamic desirable by default, we have to configure it as a trunk port unconditionally before we can use the switch port no negotiate command. And that's how we use the switch port no negotiate command. And then finally, we looked at the very end of the lesson here at the switch port trunk allow VLAN command. And again, this is why you need to get your hands on the real thing if at all possible, because this command takes some getting used to, because you've got a lot of options here at the end. I'd be familiar with how to add them with this command. Use the accept command, and that would be a none. Although you really don't want to take all your VLANs off a production network. It's not a good idea. So let's take a look then. We're going to do an exam review here, and I want to reiterate right up front, this is not all-inclusive. This is not something, you should not just study the exam reviews. This is kind of the Cliff's Notes thing. It does not have all the details, but it's a good thing when you've got just a few minutes. I know you don't always have, 90 minutes to 2 hours to watch a video, and maybe you just want to do a quick 10-15 minute review. So just some high points here and some things that I see that are common errors among exam candidates. VLANs, of course, as you certainly know by now, they prevent excessive broadcasts from using that bandwidth needlessly. They do serve as a form of security because if we put hosts in a VLAN by themselves and we don't configure any kind of routing protocol or static routing so that the other hosts know about them, nobody's going to know about them. So you can actually have a hidden subnet. Static VLANs, which are the kind of VLANs that you've been configuring all along, you just might not have known they were called that, they use the switch port mode access and then switch port access VLAN commands. And dynamic VLANs use VMPS, VLAN Management Policy Server. Inter-VLAN communication requires a layer 3 device to get involved somehow. And now that you're going after a more advanced certification, you know that there is such a thing as a layer 3 switch or a multi-layer switch. So we've either got to get a multi-layer switch involved here, or we've got to get a router in there, and the only way the router really helps is with router on a stick. The configuration of router on a stick is a CCNA thing. If you didn't see it, if you got your CCNA a while back and you don't know how to configure router on a stick, you can actually go out to my website. I've got a tutorial out there to show you how to do it. Even though layer 3 switches are becoming more and more popular every day, router on a stick still rears its ugly head every once in a while. It's a good idea to know how to use it. VMPS, our dynamic VLAN membership, uses the MAC address of a host to dynamically assign the port membership. And the mapping of the MAC address to a certain VLAN, that's kept on a TFTP server. So now, you know, it's pretty cool as you learn this stuff. Because let's face it, there are things you learn in the CCNA and you're thinking, well, I don't really have to know this. Now, you may have thought, I'm never going to use the Cisco 3-layer hierarchical networking model. You know, I'll just memorize it for the exam, and that's about all we ask you to do at the CCNA level, is memorize the 3 layers in their order. But the thing is, now you're going to use it. Well, that goes for TFTP now, because when you hear about TFTP, you think, well, you know, what am I ever going to use that for? Well, you're going to use it for iOS upgrades, as you learned in your CCNA studies, and now you found out that a TFTP server can actually help with dynamic VLAN assignments. Pretty cool stuff. Really keep this one in mind. Dynamic ports are automatically port fast enabled, and by dynamic ports, I mean, of course, they're getting the VLAN membership from a VMPS device. A couple of things you got to turn off before you can make a port dynamic. You must cut off port security, and you must turn off all trunking capabilities. Now, speaking of trunking, trunk ports are members of all VLANs by default. Access ports are members of one and only one VLAN. The native VLAN, as we discussed, is VLAN 1 by default. It can be changed. I don't care what anybody tells you. It can be changed with the switch port trunk native VLAN command. When are frames tagged? They're tagged with VLAN ID as they are sent across that trunk. And of course, our 2 routing protocols do that in a different fashion. And here it is, all on one screen, the battle of the century, ISL versus .1Q. ISL, Cisco proprietary, where .1Q is the open standard. You can also hear the phrase industry standard there. They're the same thing. ISL is going to encapsulate every single frame, where .1Q is going to add only a 4-byte header. Don't get the 4-byte header in .1Q confused with a 4-byte trailer on the ISL frames. It's 4 bytes for each one, but they're totally different, and they're even in a different location. So keep that one in mind. ISL's 4-byte trailer has a CRC value, where .1Q has a 4-byte header, and that includes the VLAN ID. ISL doesn't know a native VLAN from a hole in the ground, but .1Q certainly does. ISL has an issue with giant frames because it adds 34 bytes when it encapsulates the frames, and it may put it over the limit. Some Cisco switches have hardware that allow them to handle these giant frames. Again, you need to check your hardware or your switch capability or just about anything else to do with a Cisco device. I would like you to go to www.cisco.com/universecd. I'm even going to put it up here in the corner because it is that important. You need to be comfortable with that website. .1Q can have giant frames because IEEE 802.3ac allows it to handle frames 4 bytes larger than the maximum, 1522. Again, the major importance for the native VLAN with .1Q is that .1Q does not add a VLAN ID to frames. It doesn't add anything. It doesn't add that header at all to frames destined for the native VLAN. Bear with me one moment here. There we go. When you're trunking, as I mentioned, you see this very rarely, but you do see it. Watch your port speed and your duplex settings. If you've got mismatches on ports that are trying to trunk, you can't have trouble. Both switches have got to be in the same VTP domain. I see this a lot on practice racks. Don't forget, VTP domain names are case sensitive. You really should pick at this point in your career either uppercase or lowercase for every Cisco command and stick with it for the rest of your life. Then you don't have to worry about case sensitivity. Also, a new issue that you have to watch out for, since we have multi-layer switches now, is that the trunk has to be formed on a pure layer 2 port. And by pure, of course, on our 2950s, all of them are pure layer 2 because a 2950 has no layer 3 capability. However, on a multi-layer switch, a port may have been put into layer 3 mode, and you can just configure the command switch port on the interface, and that will make it a layer 2 port. Your brand new friend, Dynamic Trunking Protocol, DTP, it's the trunk negotiation protocol. If trunking is unconditionally on, DTP can be disabled with switch port no negotiate. We saw just a few moments ago that if it's in dynamic mode, you can't even run the command, and the switch is going to tell you. That's why I love Cisco stuff. Otherwise, DTP frames are going to go out every 30 seconds. That may be totally unnecessary overhead. Our trunking modes, dynamic desirable, dynamic auto, and on. If we want to turn the trunking mode off, we have to configure it as an access port. And of those three modes, dynamic desirable, dynamic auto, and on, the only combination that will not form a trunk is when both end ports are in dynamic auto mode. Then they're both sitting there waiting for the other one to get started. If you want to remove and or add the capabilities of the trunk to carry certain VLANs or all VLANs, you want to use the switch port trunk allowed VLAN command. Our design information, end-to-end VLANs use the 80-20 rule, where 80% of the traffic is expected to be on the local segment and stay there, while 20% or less goes across the core. End-to-end VLANs must be accessible on every access layer switch because they are just that. They're end-to-end VLANs. And the user's physical location does not matter. Finally, local VLANs are designed with the 20-80 rule in mind, where 20% of the traffic stays local and 80% of the traffic will go across the core switches. And in that case, users will be grouped by location. So that's about the end of the first video. And like I said, if you've got your CCNA recently, or you've been fortunate enough to keep studying and keep working with this stuff and retain the knowledge, you've got a huge leg up here. You've got a huge advantage. You will see a lot of questions regarding VLANs on your exam. So in the next video, we're going to take a look at a feature that you may think I forgot, because you may be thinking, you know, we went over all the VLAN stuff, but we didn't look at VTP. Well, we're going to look at VLAN trunking protocol in the next video, and there's a lot more going on with VTP than you learned in your CCNA studies. So the material you learn there, again, it's a foundation, and now at this point in your studies, you're starting to see why I tell you that your CCNA studies are the most important, because that's your foundation, and now we're building on that foundation. And that's what we'll do in the next video with VTP VLAN trunking protocol.